Welcome to Study Loop.
So for this problem, we have a dielectric with an electric flux that is given by this expression. So it's a constant times t to the power 4. We are given the displacement current, 12.9 picoamps, which, just a reminder, is 10 to the minus 12 amps at a certain time, 26.1 milliseconds. And what we want to find is the dielectric constant of the dielectric. So for this problem, we're going to apply two formulas. We have the definition of the displacement current. So it's the permittivity times the rate of change of the electric flux. And we also have the definition of the dielectric constant. It's just the ratio of the permittivity to the permittivity of free space. So it's epsilon over epsilon naught. So actually, we could just directly get a formula for the dielectric constant by eliminating epsilon here. So, for example, we could write that the displacement current is the dielectric constant times the free space constant times the rate of change of the electric flux. So that's a nice starting point because now we have what we want directly in the formula right there. So let's calculate the rate of change of the electric flux because that is the main, the most complicated term. So what is the rate of change of the electric flux? Well, we have a formula for the electric flux, right? It's up there. So all you have to do is take the derivative of this function right here. So what's the derivative of t to the fourth? Well, the derivative of t to the fourth with respect to time is 4t cubed. All right, so that's a basic result from calculus. So that's the derivative, and therefore the rate of change of the flux with respect to time is just 4 times 8.76 times 10 to the 3 volt meters per seconds to the fourth times t cubed. And now we can just solve for the dielectric constant. So the dielectric constant is the displacement current ID divided by epsilon naught times the rate of change of electric flux. All I did was rearrange this equation here. And then we can just start putting our numbers in. So this is upstairs, we have the displacement current, that's 12.9 times 10 to the minus 12 amperes. And downstairs, we have 8.85 times 10 to the minus 12 farads per meter. That's epsilon naught. And then we have our rate of change. So that's 4 times 8.76 times 10 to the 3 volt meter per second to the fourth times the time, 0.0261 seconds. And remember, that is cubed. So all of that is in the denominator. And now that's just a number, so we can calculate it, and you should find that that is roughly 2.34. The dielectric constant is unitless, so we don't have to worry about units, and that is the full solution to the problem.